object that has reflectional symmetry that can be cut down the middle and be the same on each side.
Symmetry is an object that can fold and still be the same on both sides. Half is a mirror image of the other half.
Reflectional symmetry is when you take an object and you draw a line straight across, and one side projects the exact same on the other side.
Reflectional symmetry is where if you cut a line down the middle of an object and it's the same on both sides. So for an example, like a person.
This is my friend, my scarecrow, and it is reflectional symmetry because if you put a line down it looks the same. It has arms going out this way and it has legs.
My reflection thing is this bird, so if I reflected it, it would turn like this, and that's how it'd be reflected.
The reflectional symmetry on the phone is if you draw a line, the flat thing here has the same on this side, and
Reflectional object is a tree. If you cut it right down the middle, then it can fold right to left.
This leaf has reflectional symmetry because if you fold it, it has the same thing on both sides.
Rotational symmetry means that you can spin the item how many times and it'll return to the same place.
Rotational symmetry is where if you have an object and you rotate it, it's basically going to be the same.
Rotational symmetry is a shape that is always the same shape when you turn it or move it.
yeah, it's basically where an object rotates around a grid and you find the coordinates and then you find the degrees it rotates around.
Rotational symmetry is an object that can turn around and go back to how it was.
And the object that I have is a starfish. This object has 5-fold rotational symmetry, so if you rotate it 72 degrees, that means it will line up again on itself.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My object is orange and it has 10 wedges, and if you spin the orange all the way around, it'll line it back up to how it was.
How many times?
10 times. Means it has 10-fold symmetry.
A starfish, and yeah, it.
What fold rotational symmetry does that starfish have?
5.
How do you know?
Well, because there's, 5. How do you say that?
I guess legs.
Legs, yeah.
A flower petal.
And can you explain how this flower petal has rotational symmetry?
So if you spin it 5 times, it'll go back on itself.
So that means that it has what fold symmetry?
5-fold symmetry.
Translational symmetry is where if you move an object a certain distance to the right, left, up, or down, it will look like itself.
And translational symmetry is a pattern that repeats along a straight line.
Translational symmetry is when a shape shifts along a straight line but does not change shape or size.
Translational symmetry results from moving a figure a certain distance in a certain direction.
Now, if you have this ball, I guess, it translates on the x-axis from like 1 to 5 along one quadrant. It's a piece of wood, and the length of a strand of wood goes translationally across.
This leaf has V shapes going down, and as you go down the stem, you can see the translational symmetry.
I'm doing for translational symmetry a fence, so if you slid over a box, it would be itself, and that'd be a pattern.
Translational symmetry is a garden box. If you slide one piece of wood down, it'll be the same.
A little beehive thing up there, and that's translational symmetry because if you move the object one hexagon to the right or left, it still lines up with itself.
The definition of congruent objects is two items that look exactly alike.
Congruent means two objects are exactly the same.
Congruent means the same sides and segments have the exact same length.
Congruent is when the object is exactly the same shape and size.
These two flowers. Well, because the size and the shape and the color and the way that they're placed by nature are pretty similar.
Two dandelions, and they are congruent because they're exactly the same.
So, Ian, are those two strawberries congruent?
Yes,
Why are they congruent?
because they're the same size.
Dilation is when there are two objects exactly the same shape but different sizes.
The dilation definition is one object that is bigger than its twin. Definition for dilation is an object that are the same shape and different sizes.
So imagine this small little blue ball. And then all of a sudden it gets really big. And that's a dilation.
Dilation is where you get one object that is the same and one of them is bigger and better. For example, this is little me. He is small, not as awesome, and then I am bigger Jax. Right here, big Jax, awesome Jackson, better Jackson. And that is dilation.
My dilation is my smaller finger expanding into my bigger finger, and this finger was measured at 3 inches and this one was 4. So this finger expanded into this one by a factor of 1.3333333.
The big one is 4 and the length of the small one is 2.5 and the dilation is 1.6. This one's a dilation of this one. This one's 3.5, this is 3, and 1.6 is the dilation.
Dilation thing is a long piece of strand of my hair, which is 8. And then the shortest piece is 2, and my dilation factor is 4.
This stick is 19 inches, this stick is 5 inches, and the dilation factor would be 3.8 because this stick can go into this one 3.8 times. First 10 Fibonacci numbers, it goes 1, 1, and then to 2, and this is because 1 plus 1 equals 2, and then you're going to go to the next, 1 plus 2 equals 3, 2 plus 3 equals 5. So you always go back to one number and add it to the next.
Here is the Fibonacci sequence. Start out with 1 and 1. That is going to equal 2. And then you add these two. It's going to be 3. You add these two. It's going to be 5. You can add those two. 8. So what you're doing, you just kind of go on and on and on and on. And how you do it is you get your first number and your second number, you add it, and then that answer you put right here, and then you go back to this one and you add these two, and then that answer comes right here, and then you add these two, and it just goes on and on and on.
Fibonacci numbers, and the fractions would be 1, 1, 2, 1, 3, 2, and 8, 5.
Missed one in between.
Factor.
Good.
These fractions are the equivalent, or these decimals are the equivalent to the fractions, and as you can see, it keeps on going until 1.6.
1.6 is the golden ratio.
1 plus 1 is 2, and then 1 plus 2 is 3. 2 plus 3 is 5. When we connect all the corners together, it'll turn into a Fibonacci pattern.
Fibonacci sequence is a series of numbers that creates a spiral based on adding two numbers.
My object is a pineapple. It's spiral shaped, and how it's spiral shaped is all these like round things. They can like spin round and go back to how it was.
Yeah, same on both sides.